Hi, this is an example about binomial distribution. A manufacturer produces a certain type of circuit board. Of the total production, 5% are defectives. Find the probability that a randomly selected sample of 20 circuit boards will have A. Exactly 2 defective boards, B. At most 2 defective boards. Is it rare to find at least 3 defective boards from a sample of 20? Explain. Let's begin with some notation. We let x equal the number of defective circuit boards. Since we are doing the inspection for 20 circuit boards, we are doing the experiment 20 times. So n equal to 20. The number of possible value of x, which is the number of defective circuit boards, could be 0, 1, 2, 3, 4, all the way to 20 since we are inspecting 20 circuit boards. In this case, success means you discover a defective circuit board. Let P be the probability of success. Now, according to the question, the probability of success is 5% because 5% of the circuit board are defective. So the probability of success is 5%, which is 0.05. And Q, which is probability of failure, is 1 minus P. In this case is 0.95, 95%. Right? Here, failure means the circuit board is okay. This is a model of binomial distribution. If we assume that P, the probability of getting a defective circuit board, is always 0.05. And in the standard notation, we write x is binomial distributed with n and p as the parameter, where n is equal to 20 and p is equal to 0.05, which is 5%. To answer for part A, exactly 2 defective circuit boards, that means x is equal to 2. The probability is 20C2 p squared q power 20 minus 2, where p is 0.05, q is 0.95. So then we press the calculator. Okay, so I call up my calculator. We are now in the computation mode, so select 1 and then 20C2. We can enter 20 shift C2 times 0.05 power 2 bracket 0.05 close bracket power 2 then times 0.95 close bracket and power 18, which is equal to 0.18867. So this answer is equal to 0.1886768. We can also get this answer by directly using the distribution of this calculator. So this calculator again, let me go to menu and go to distribution. So distribution is under here. So equal binomial probability density function, which is 4. And then we are using variables. So this binomial distribution, as I want to find the probability where x equal to 2 equal n equal to 20. The probability of success is 0.05. 0.05 equal 0.18867688013. Move on to part B now. What is the probability of at most 2 defective bots? That is, the probability of x less than or equal to 2, which is equal to the probability of x equal to 0 plus x equal to 1 plus x equal to 2. Then we're using the formula for probability density function. We'll find that the first term for x equal to 0 is 0.35848. Second term for x equal to 1, the probability is 0.37735. The third term, the probability of x equal to 2 is 0.18868. The sum is 0.9245. We can also use a calculator. In this case, I go to menu, again distribution, 7, and then I select binomial cumulative, which means you go down and find the binomial cumulative distribution 1, and then select variable. Now x less than or equal to 2 here, and number of experiment is 20, and probability of success 0.05. So enter all this number, you find that the total probability for x less than or equal to 2 is 0.9245. The last part, we ask, is it rare to find at least 3 defective bots from a sample of 20 as print? So we find the probability of x greater than or equal to 3, where x is the number of defective circuit boards. So that is probability of x equal to 3 plus probability of x equal to 4 all the way to probability of x equal to 20. They are altogether 18 terms. So that is too much for calculation. However, we can take a simple way out by using 1 subtract the probability x equal to 0, subtract the probability x equal to 1, subtract the probability x equal to 2, which is actually we did in part B already. 1 minus the probability of x less than or equal to 2. We get 1 minus 0.9245, and so it's equal to 0.0755. Now this 0.0755 is more than 0.05. So we conclude that it is not rare to find at least 3 defective bots from a sample of 20. Alright, we say that this is a not rare event.